Lab equipment. It's like the tools of a scientist, right? We use it to explore the world around us. But before we can trust the results, we gotta make sure the equipment is up to snuff. That's where equipment acceptance comes in. Imagine baking a cake and your oven's temperature is off. Disaster! Same goes for lab work. If the equipment isn't working right, our experiments won't be accurate. And that means our conclusions might be wrong. That's why every piece of new equipment, whether it's a simple scale or a fancy spectrometer, goes through a special checkup when it arrives at the lab. We call this process equipment acceptance. It's like giving the equipment a science test before it can join the team. So, how do we give lab equipment this science test? First, we need to know what we're dealing with. Every piece of equipment comes with a set of instructions and specifications from the manufacturer. These are like the equipment's instruction manual and report card rolled into one. The instructions tell us how to use the equipment safely and correctly, while the specifications give us the details about its performance. Think of things like how precisely it should measure, how high a temperature it can handle, or what chemicals it can come into contact with. During equipment acceptance, we carefully check the equipment against these specifications. We want to make sure it matches up perfectly with what the manufacturer promised. This step is super important because it ensures we're using the right tool for the job and that it can deliver the accuracy and precision we need for our experiments. Speaking of accuracy and precision, these are like the golden rules of laboratory work. Accurate measurements mean our results are close to the true value. Precision means we get similar results every time we repeat an experiment. Think of it like throwing darts. Accuracy is hitting the bullseye, while precision is hitting the same spot on the dartboard every time, even if it's not the bullseye. In science, we want both. That's why during equipment acceptance, we verify the equipment's ability to deliver accurate and precise measurements. We might run some standard tests or compare its performance to a reference standard. This helps us make sure the equipment is up to the task of generating reliable and trustworthy data. Section 4. Returned equipment needs a checkup. Sometimes, lab equipment needs to take a little trip outside the lab. Maybe it needs to be calibrated by the manufacturer, or perhaps it was borrowed by another lab. Whatever the reason, when equipment returns from an off-site adventure, it can't just jump back into work. It needs another checkup. Just like with new equipment, we need to make sure the returned equipment still meets the manufacturer's specifications. Has its performance changed? Has it been damaged in transit? These are all questions we need to answer before we can trust it again. This process might involve running similar tests to those we do during initial equipment acceptance. By verifying the equipment again, we're making sure it's still in tip-top shape and ready to deliver accurate and reliable results. It's all about maintaining that high standard of scientific rigor. Section 5. Keeping equipment in tip-top shape. Now, we can't just expect lab equipment to stay in perfect condition forever, right? Just like our cars need regular tune-ups, lab equipment needs preventative maintenance to stay in tip-top shape. Preventative maintenance is like giving our equipment a spa day. It involves regular cleaning, inspections, and sometimes even replacing worn-out parts. Think of it like brushing your teeth and flossing. It helps prevent bigger problems down the line. By sticking to a regular preventative maintenance schedule, we can extend the life of our equipment, reduce the risk of breakdowns, and most importantly, ensure it continues to deliver accurate and reliable results. Remember, well-maintained equipment means trustworthy science. Section 6. Dealing with faulty equipment. Even with the best care, sometimes lab equipment throws a wrench in our plans and decides to act up. Maybe it breaks down, starts giving wacky readings, or just doesn't behave as expected. What do we do then? Panic? No way! We have procedures for that. First things first, safety. We need to make sure the faulty equipment doesn't pose any danger to the people or the lab. Then, we take it out of service and label it clearly as faulty, so no one accidentally uses it. Depending on the problem, we might try to troubleshoot it ourselves using the manufacturer's manual. But sometimes, we need to call in the experts, like a qualified technician or the manufacturer themselves. They have the know-how to diagnose the issue and get our equipment back in working order.